It has sensors, it has actuators, it has a computer, but the computer's running machine learning-based AI. And the implication for this is that it's not just processing information, it's not just giving answers, it's sensing the outside world and reacting to the outside world, and in most cases, physically affecting the outside world.
I hear a lot about physical AI, and I think this is going to be the theme of 2026 among those people who go to the Consumer Electronics Show. So let's start with the very basic question. What is physical AI in your opinion?
I look at physical AI and embodied AI as amounting to the same thing. And the idea is you have some AI technology, which these days means machine learning, and it's inside a computer, and the computer is inside what used to be called an embedded system or maybe a robot. It has sensors, it has actuators, it has a computer, but the computer's running machine learning-based AI. And the implication for this is that it's not just processing information, it's not just giving answers, it's sensing the outside world and reacting to the outside world, and in most cases, physically affecting the outside world.
Right. So it's actually it's a lot going on there. We're talking about the whole package here.
Yeah, you're not just showing it a picture of something, you're showing it a picture of something and say, now change that something to be something else, for example. And this is a classical robotics thing that's been around for decades. Show the robot a picture of a world and have it move something around inside the world. That's physical AI. That's embodied AI.
Okay. All right. So, I want to go back to this original idea that why do we need to use AI for this? Robotics has been around for a long time. Growing up in Japan, I've seen the robotics arms being used in automotive factory and so on and so forth. Why do we need to use AI now?
Well, there's very limited forms of things like robotics that don't actually sense the outside world very well. And there's really hysterical videos of a robot where you put its thing in the wrong place and it just smashes into it because it's programmed to say, the thing I'm picking up is here. That's where it is. Don't need to look, don't need to feel, just it's there. And if it's not there, whoa, crazy things happen. Sort of the robot version of Who Moved My Cheese, right?
Yeah.
It has to be. And so production lines are so controlled that you can say, no, that screw's always going to be there and that nut's always going to be there and that piece of, and that's fine.
Right.
But the more general version of robots, the type of robotics people have been doing research on for decades are, well, no, the real world mostly isn't like that. You want to pick up a block, you have to figure out where the block is, what the orientation is, line yourself up, grab it. And that's more hardcore robotics. And that's been AI as long as those kind of robotics have been around. It's basically been an AI experiment. So robotics and AI kind of grew up together. So the reason you need AI for an embodied AI, physical AI robot, is that it's dealing with systems that you can't handle with conventional programming. And there tend to be a few things that you really need it. One is if you want natural language understanding, natural language interface, AI is kind of how you have to do that. It's always been AI. It's just a question of what flavor AI. Another one is if you need to sense the outside world, and you need to say, oh, I have a camera image of this thing. What's the thing? Well, that's been a core area of AI as well.
Right.
And conventional programming struggles with that. And it turns out machine learning is really, really good at both language interpretation and understanding the physical world. ML, machine learning has been the thing that really made that feasible at scale, where it was always a struggle before. And the last one is people really end up doing machine learning based AI if they have an unstructured situation. And so if you knew how to write perfect, complete requirements, maybe you don't even need to use machine learning and AI. But the real world is a messy place. It has lots of weird things. It's hard to describe. Is that a person? Well, what's a person look like? It's really hard to describe that. So instead, what do? You say, well, here's 1,000, 10,000 pictures of people. By when I say person, I mean something that looks like those kind of pictures statistically. And, oh, okay, now I know what people are, right?
Right.
And being able to deal with a world that is hard to specify, and in particular has a lot of variety, and you have to say, well, That's a person regardless of skin color, regardless of hair, regardless of what they're wearing. You have to know what a person is. Those types of things, machine learning based AI is pretty good at.
Yeah.
And if you want to build that kind of thing, then you sort of need it. And by the way, if you have a physical system that's interacting with the physical world, those are exactly the kind of problems you run into.
All right. So good example might be, say, you have a robot working in a warehouse, and in warehouse, the robot has to deal with different sizes or shapes of packages, maybe?
Well, if you're a robot in a warehouse and you only make one product and it's a standard size and it always goes in the same place, you don't need as much
You don't
AI.
need, okay.
As much as
Yeah,
is if you have 10,000 products and tomorrow 100 products you've never seen before are going to show up and they all have to go on shelves or come out of shelves and go into boxes and they were thrown into bins by people or by other robots that weren't careful, so the orientation is weird and they're different colors and some of them have tears in them in the packaging. You have to figure out that they're sort of broken and set them aside. It's even in a constrained environment like a warehouse, AI is going to really help you a lot with that kind of those kind of
yeah.
situations.
All right. Very good. Well, having said that, though, tell us about the fundamental technical challenges associated with this physical AI or embodied AI.
Well, it used to be trying to figure out what things were, but that's what machine learning is solving for us. The catch is
Okay.
once you use machine learning, it's good at things it's been taught, and it's really good at the average case. And it's good at saying, well, I've learned that, so I know what it is. What it's really bad at is when it encounters something that's unusual. So people call it edge cases, right? When you
Yeah.
encounter something you haven't been trained on, or maybe you've seen a few times, but you've seen it so few times you didn't really pay attention that much in the training data. So it's
Yeah.
underrepresented in the training data, or maybe missing the training data. Machine learning is going to struggle. That's sort of the first half. The second half is machine learning has no common sense at all. People want to talk about it reasoning and thinking and interpreting. No, no, no. It's statistical pattern matching, which can do really spooky things at scale. But ultimately, if you get it outside its comfort zone, it fails in an incredible manner. It just the best way to describe it is it has no common sense. And so you have to be very careful because the reason you're using machine learning is you're operating in an open, very complex environment. Well, that open, complex environment is guaranteed to have things you didn't train on. And instead of failing gracefully and saying, "Oh, I don't know what's going on," machine learning is terrible at saying, "Oh, I don't know." It's just like, "Oh, it matches this thing. Sure, why not?" And you just go for it, and it's completely inappropriate. So the real challenge is dealing with the rare events, and that is going to be a challenge forever with this technology. It's just a fundamental limitation of this technology. Can use this technology in those environments? Yeah, but we need a playbook other than more data because more data doesn't solve infinity. It gets you further out into the tail, and in some environments, it's close enough to be useful. So training at scale gives you more usefulness, but there's always a small amount you can't handle. And the question is, are the consequences for not handling that small amount no big deal, or are they a problem? If you're trying to tell me which movie I might like and you're wrong 10% of the time, I'll live. If you're wrong 1% of the time, that's amazing. I want that service, okay? But if you're saying we're going to detect kids in crosswalks 99 times out of 100, well, that's a real problem for that 100th kid, right? And so the magnitude of the cost of the error is what really limits the applicability of this technology.
What would be the fundamental societal challenges?
Oh, there are so many, but let me try and pick something compelling. I think a lot of them boil down to people want to use AI technology these days, again, machine learning based AI. They want to use AI to supplant the role of people because people are expensive and people make mistakes and machines are cheap. Machines actually make mistakes. We just like to pretend they don't, all right? And therein lies the rub that when you have a person who's responsible for something and they make a mistake, they're accountable and they have incentives to avoid the worst mistakes, or if they make a mistake, figure out how to mitigate the severity of the consequence. uh, because they're accountable, and in part because they want to do the right thing, and in part because they might be punished, they might lose their job. The error rates are quite low, and people, there's a reason it's called human error. People make mistakes. That's what people do, and people who want safe systems design systems that a human error is easy to tolerate or correct or write out. You just design the system so it's that way. Now you replace that with machine learning based AI, and a couple things happen. The thing about safety is safety isn't about the average case. Safety is about the rare high consequence event. And machine learning is at its worst for rare events. And that's the only place safety really matters. Because if
Yeah.
you can't drive down the street for a block without hitting something, that's not a safety problem. That's a you don't know how to drive problem, right? And
Yeah.
fatality rates are up in the 100 million mile kind of thing. That that means it must be a rare event, right? That's the whole
Yeah.
point.
Yeah.
And that's where machine learning struggles is at rare events. So when you replace something that has false confidence in high
Mm,
severity rare events, you've got a safety problem. But you also have this issue that there's no accountability. Well, if a computer kills someone in a factory because it works properly for a year and then just goes nuts and kills somebody, and the behavior it displays would have been attributed to being a bad actor if they were a person. Okay.
I
Or it
see.
makes some sort of, it's a decision system and it makes a decision that's dangerous and a person would be held accountable. Well, what do you do now? Do you find a person and blame them? That's called the moral chromosome. It's a very popular
Yeah.
strategy in these systems, unfortunately, right?
Right.
Every
Right.
time you hear pilot error in an aircraft, there's a very high chance that's not really the whole story,
Not
right?
what it
Yeah.
is.
So
Yeah.
this is a well-worn playbook. But if you have a machine that makes a mistake and no one's accountable, where's the incentive to get it right? Where's the incentive?
Oh, I
If no
see.
one's if literally no one's
No one's
accountable for a
accountable.
bad thing,
Yeah.
then whoever was involved in creating that has no incentive to get it right other than sales, right?
Yeah.
And the system we
Exactly.
have, you can easily make money building something just a little bit dangerous, but more dangerous than people really want it to be. Right? There's
Indeed.
this zone in between where it may be 2 or 3 or 10 times more dangerous than it should be, but you can still make tons of money just by buying insurance or something, right? Because the
Uh,
insurance premiums are still affordable.
right.
And so the societal problem is how do you hold a robot accountable in a situation in a way to provide the proper incentives? I didn't say it had to be perfect, but you want
Right.
to make sure that the people who have the ability to have good outcomes are properly incentivized to get the good outcomes.
Right.
And tort negligence law is how we do that for people.
Right.
But it actually doesn't even apply to most robots. They're not even exposed to that kind of liability.
Yeah.
And product liability is very expensive, very difficult to pursue. So the checks and balances for behavior,
Yeah.
if you have a person who used to do a job and now a robot's doing the job instead, the
Right.
checks and balances on behavior that exist for people do not exist for robots. But a
Yeah.
lot of it comes down to we don't have an accountability mechanism for machine learning when it supplants human judgment.
Interesting.
And blaming people won't fix that.
Yeah, that's true. But is no, it won't fix it. But at the same time, you can see the future where the whoever who was using the robots are the ones to be responsible for making sure that robots did not go haywire, in other
Well,
words.
and that doesn't work
Yeah.
because of automation complacency and automation bias and the way humans
Right.
are. And so, just to pick an example, if you have a physician who's relying on a embodied AI system to tell them whether they need to do a medical intervention,
Right.
and the embodied AI system says, no, no, this patient doesn't need it. And
And
an attentive physician would have noticed some signs that said you should intervene anyway.
right.
But the corporation has told them the insurance won't pay if they intervene and the robot says no, or they'll get fired if they have too many interventions against the robot, or they're tired and they're sleep deprived and the robot's been right 1,000 times before, so they're really not paying attention. And this isn't about physicians, this is about anyone. I was just giving a concrete
Right, right,
example.
right, right.
And by the way, I'm not saying that makes them a bad person, it makes them human, right? And so where's the accountability for the robot who occasionally makes the wrong call in a situation where we have known for decades that people are going to tune out? That's just human nature.
Yeah.
And so in those situations where the robot is compromising or is infringing on the judgment authority of a person or supplanting it. Take your favorite word. When the
Yeah.
machine is undermining the autonomy
You,
of the person and grabbing a piece of it for itself,
yeah.
if that robot doesn't have any accountability, you're going to get bad outcomes. And that accountability has to be the manufacturer. Why? Because things like tort negligence law are designed to provide an incentive for the person who can change the outcome to change the outcome. And it's the manufacturer who can change
Sure.
the outcome,
Weekend, yeah.
not the person using it who may not even understand the theory of operation.
Right. As we go into this frenzy of everybody's talking about physical AI in 2026, companies who are developing technologies, companies who are pushing the concept of physical AI, there are a lot of tech companies out there. What are the questions that should a journalist like myself be asking them?
I think the questions we already asked are kind of the questions you want to ask
Yeah.
them. What?
Yeah.
So you said AI. What did you mean by that? Right?
Yeah.
And is it just an AI chip you duct taped onto the side so you can say there's AI inside, right?
Yeah.
Or and what did you mean by it? Did
Yeah.
you mean it runs software?
Yeah.
You're going to see some of that, okay?
Yeah. Yeah.
And then how are you dealing with the hard problems? The hard problems are high consequence edge cases, right? And the other problem is how you are managing accountability. How exactly does that work? Understanding that the law does not currently provide the set of incentives really needs. So how are they going to do it? And some of the answers, and I know this is something you've looked into. They say
Yeah.
we accept liability. Well, what did you mean by that? Did you mean just
Yeah.
product liability? How about criminal liability for the driver
Indeed.
you told not to pay attention that they
Good.
gets into a
Yeah.
crash, right? These are tricky topics, so you're never going to get a perfect answer. And
Right.
again, the technology does not have to be perfect to be useful, right? It's okay for
Good.
technology to make a mistake as long as the mistakes are not high severity, life critical.
Yeah.
And so if you see how life critical technology, well, it's like, well, these things are going to make mistakes. What's your plan?
Yeah. Yeah.
And if the answer is to blame the operator, that's a bad plan. If the answer is no, no, we've done a lot of human subject studies where we're sure that the mistakes this make are always caught by the people because we have a carefully considered design. Okay, that's really getting to be an interesting answer. What exactly is the accountability management plan here?
Interesting. My last question, which wasn't in the list. People often told me that if I ask some questions about such things you just mentioned, Junko, don't worry about it. This system is built or designed with the human in the loop. I mean, this human in the loop seems to be the throwaway line that people, make it sound as though that they're really responsible for me designing these products. I mean, I'm very bothered by that.
Well, did you do human subject tests? Or is it a bunch of engineers who said, well, I can use it, so it'll be fine? Okay.
Yeah. Yeah. How do you define
There,
that? I mean,
there was
yeah.
a query from a regulator to a company that when you decoded it said, so do you actually have any human factors experts? So ask them, what are you actually doing about the
Yeah.
human factors? Is it when you say human loop, is that just a buzzword, or did you actually do
Meaning,
actual best practice? There are people who have degrees in this to employ any, right? Ask
right.
that part. And then ask, well, what's the human's role? And if the human's role is to pay attention to a boring system and stop it from doing
Yeah.
harm once in a great while, we've known since 1950 that does not work.
Okay.
So are they asking now, did you mean humans in the loop or did you mean superhumans in the loop? Because
I
superhumans are in
see.
short supply. But often when they say human in the loop and you listen to what they're expecting of the human, what they really mean is superhuman in the loop and it's your fault for not being superhuman. And that's a problem.
All right, very good. This was a lot of fun. Thanks for give me enough ammunitions to go on.
I
And
enjoyed it.
yeah, we'll talk again soon. Okay.
Okay, look forward to it. Take care.
Thanks.